Hey there, I'm Scott, and this is Tangents. Well, as I'm recording this, Perseverance just landed on Mars. Um, I don't know if that means anything to you, but it means a little bit to me. I'm just blown away by the fact that this works. I remember years ago, shortly after I finished graduate school, I had a friend named Devin, and she was finishing her master's, working on her master's thesis. We were sort of studying together, and she was telling me about this thing that was gonna go to Mars, and then it was too big to just drop with a parachute. And so instead of having that or like a bouncy ball or anything like this, the plan was, and excuse me for almost laughing at this because it's insane. But the plan was to have it enter the atmosphere and come down, aerodynamically steer a little bit, have a supersonic chute, and then down close to the ground, jettison the chute, have rockets support a platform, and then like a crane, drop this thing down, cut the cable, and then have the crane thing just fly off and crash. And I'm here, and I'm somebody who, I like engineering, I like technology, I like autonomous systems and this kind of stuff. And still, I'm listening to it, and it just seems like that's not gonna work. There's no fucking way in hell. This was, of course, Curiosity, and this was the time we were talking was just I think it was just before they announced that it was going to target Gale Crater. There were a couple of landing sites in process, being debated, and she does planetary like her thesis was on dust devils on Mars, so kind of planetary geology sort of stuff. And she saw something come up about this, and that's what spurred us on this whole conversation. And it was amazing. I mean, first off, I guess it was 2012 when that landed, if memory serves. And I watched that, and you see the Mohawk guy, and all of these people. And at that time, this was a landing with much less hype, but also no video, nothing too cool coming. Uh, Today's landing on Mars of Perseverance uh, had unfortunately not live high definition video. We're a number of years from being able to support that, but nearly live in the sense that by the time you listen to or watch this, you can probably download a high definition video of that landing, which is nuts. I mean, the evolution of that technology on the scale of like a human lifetime, when you look at just how far things come, and it's not instant, it's not overnight, but it's pretty fucking impressive. This did the sky crane again. As far as I can tell, nailed it. This one had some improved autonomy. It's always crazy to see how far behind space hardware is compared to stuff that you can do on Earth. Like in terms of, I mean, you have several problems. You have radiation, which means that you can't use very small processes. The smaller the transistors, the more susceptible those are to cosmic rays, and Mars doesn't really have much of an atmosphere nor a magnetic field. So even on the surface, radiation is a pretty significant problem. You can't use the latest chips also because you want things that are heavily validated. And this is not even including the fact that the landing is years before, and in addition to that, it's not like you just grab the latest thing off the shelf and then put it in. It takes years to design and build these things. So this was a vision system, terrain-based guidance, and it was working at about 1 frame per second, which compared to the stuff that like I play with a lot, is very, very slow. And you'd think also for space hardware you'd be able to do more, but you just don't have the power. You can't have the latest stuff. And, you know, given the constraints that they were subject to, pretty good thing what they were able to do. And it worked. It worked. It's amazing. I'm amazed also, like we're to the point with control systems and just dynamical systems in general, that you can pretty much build something out and validate it in a simulation before you put any hardware together at all. And you can have, even when it's a crazy, rocket-powered crane, you can have a pretty high confidence that it's going to work right on the first time. Even if it's a rocket doing a belly flop maneuver, you can know with decent confidence before you even build the thing, let alone launch it, this will probably work. And, you know, I definitely, I mean, I don't know. I'm cautiously optimistic about where we're heading in terms of space hardware. You have, I have a lot of problems, obviously, with Bezos and Musk. But I also don't mind the fact that they're pushing the envelope in terms of this technology. So, the fact that they're doing it rather than a functional government research project, not the greatest thing. But the fact that it's happening, I'm very excited about. I'm very excited. And again, not a fan of Musk's. The bullshit with Bitcoin and all this stuff is dumb as fuck and just offensive and irritating. But same time, he's building this Starship thing. Well, his SpaceX is building it. I think he's technically the chief engineer or some bullshit like this. Strictly speaking, I think that's extremely generous. But his team is certainly doing it. And despite the couple of crashes that they've had with serial number 8 and 9, I'm very confident that if not serial number 10, very soon they're going to stick the landing. And pretty soon after that, they will have a single stage to orbit vehicle, that's not the design intent of Starship, but it will be capable of launching to orbit and then landing itself, which is pretty fucking crazy. The one limitation of chemical rockets is that there's something, the tyranny of the rocket equation, which is basically that the more fuel you put in, the more fuel you need to lift the fuel. So if you're trying to get a certain amount of delta V, a certain amount of change of velocity, you need to keep pouring in more fuel, and as you're putting in more fuel, you need more fuel to compensate for the fact that the fuel itself has a lot of mass, and so you end up with something that basically is bounded in terms of what you can do. And at Earth's gravity and radius, all of the planet's parameters that we're stuck with, basically that means if you're using chemical propellants, you can just barely make single stage to orbit work. This is the reason that we almost always see multi-stage rockets, because single stage to orbit, in a very optimized system, you can get up there with basically no payload. And you can get back down, assuming that the landing and all of this other stuff works, which I believe will work. I'm pretty confident. And so at a certain point, you'll have that. It's going to be on top of the super heavy booster, which is also capable of I guess it would probably, it almost must be single stage to orbit itself, but it's mainly intended to lift the Starship and then let Starship act as a second stage so you can actually have a usable payload. Although on a planet like Mars, or certainly the Moon, Starship can easily get to orbit and land, and probably, on the Moon do it a couple times on a single tank, which is pretty fucking nuts. So I'm excited about certain things about where the way things are going and where we are, all of this. It's frustrating how much certain things like that are kind of hopeful and optimistic. And then you also have things, and to some extent, these are even intertwined. We have issues like climate change. You have Musk, who is doing shit like giving a bunch of, I mean, the $1.5 billion to Bitcoin is bad. But what's worse about that is the halo around it. People see him doing it, and then that makes them jump on the bandwagon and also have their get rich quick dollar signs in the eyeball thing, which means that they start throwing more hardware and energy at it, which basically just, is terrible for the environment, our environment. Similarly, Starship and Super Heavy are going to be powered by methane. Methane is a very strong greenhouse gas. Depending on how you do the accounting, 20 to maybe even up to 80 times more powerful of a greenhouse gas than CO2. The reason for the disparity there is just it has a longer lifetime in the atmosphere. So if you're factoring, like different time horizons, you get a pretty different number. But needless to say, much worse than CO2. And it's just like, is it a lot worse or crazy worse? It's pretty bad. So you get that, and technically speaking, you can create methane using, say, solar power and atmospheric CO2, atmospheric water, hydrogen from that. The problem is that it's very energy intensive, and so most methane, especially in Texas, is just mined by fracking. And Musk is going to do this himself. And the fact that you're doing that, you're basically extracting something that currently is sequestered in the ground and you're putting it into the air. Now, granted, a lot of it will be burned, but in the process of doing this, you're always going to have leaks at the well. You're always going to have leaks in storage and transfer. You'll have leaks in the actual vehicle and venting, which is bad. So you're putting a lot of bad stuff into the air. The CO2 also, not as bad as the methane, but the CO2 that you're going to put in the air from that is also stuff that was formerly carbon that was sequestered. So it's it's not good. Is what I'm saying. Especially when you start, like, if Starship works the way that it's supposed to work, and I think it's plausible that he could get the launch frequency up to, in a few years, say 1 per day, and in a decade, several per day, at least. I mean, when you start talking about things like that, it starts becoming enough of a thing that you start worrying about it. Now, granted, compared to, and I don't know if this is reassuring, but compared to, say, air travel, it's a small drop in the bucket, but it's still a substantial amount for one endeavor. Now, on the other hand, you can always argue, well, maybe we'll start using these other processes and then creating methane from atmospheric gas, and then, then it's essentially carbon neutral. Although, if you imagine, I mean, it's an interesting thing to be concerned about, but if you do have that process down, you're still making methane from CO2, and again, the methane is going to be much more potent of a greenhouse gas than the CO2. So maybe it's not the greatest thing, especially if you're leaking a lot of it. Hopefully you contain it, but who knows? That being said, Perseverance is on the ground, or on the Mars. I don't know I guess you'd say that on the ground on Mars. There's a helicopter, which the name is escaping me right now, and it's going to kill me. The first helicopter, as far as I know, on another planet. That's pretty cool. And Ingenuity. God, I knew it was in there, but it was like not coming to me. I'm excited about this, other things notwithstanding. I really do believe, barring a catastrophe, we're probably on track, certainly to have people back on the moon in a few years. Like, I really think in a few years, realistically. And then on Mars within maybe a decade or so. Like, I granted it's already 2021, it's very fast, but I think it's not that unrealistic to think by 2030, give or take a couple years, we have people on Mars. And that will be fucking crazy. And when that happens, also, that'll be probably, I mean, it won't be live video, but the light delay, assuming that you're using the same kind of transfer orbit that we use, and there are a couple windows, I think every couple of years, where Earth and Mars are not in the closest proximity, but they're in a position where the trajectory from Earth to Mars is the easiest. And I'd assume until you start having much better propulsion systems, that's probably what you use. And so you imagine probably the light travel time will still be, I think it's periodic. So I think each time this happens, it's about 12, 11 and a half, 12 minutes, whatever this one is. So you can imagine, after some number of these cycles, having better, like a small satellite network on Mars, where you could actually get like essentially as live as possible, subject to light travel time, video stream of people landing there. And I maybe I'm crazy, but I really think that could very easily happen. I'm not sure that the numbers of people that he's talking about will necessarily be realistic in a reasonable amount of time, but I'm not sure that they're not. I do think we're going to get to the point where having people, like relatively regular people, going to space to live and work will be a thing. And, whether they're mining asteroids or, working in the service industry or doing whatever, I think that's going to happen. I do worry, it's not very hard to imagine someone like Musk giving people essentially an indentured servitude. Yeah, we'll take you to Mars, but sign this contract and you're basically a slave de facto, because you have, a ton of debt that you have to work off, and you've really not a lot of options while you're there, at least at first. So I worry about where that goes, but that's an interesting and weird problem to have. I really do. Now, whether or not it's worth putting people on Mars, that's a debate for another day. I don't want to get into it. But I do like the idea of becoming multiplanetary. I really like the idea, and again, I don't want to say positive things about Bezos, but Blue Origin is planning not so much like focusing on Mars as Musk is. The thing about Mars that I do think you have to think is that Mars, it's very photogenic, and you can kind of wrap your mind around it a little bit more. If you're building, say, an orbital habitat, unless you've got, say, an O'Neill cylinder, and you've built it in such a way that you basically have your own little private island in space, short of that, it's really hard to think of, like even a nice space station as something that's that cool as a destination. Whereas landing on Mars kind of feels like a thing more. But in terms of practicality, putting people in orbit, and whether they're either in orbit or out into the asteroid belt, that's a pretty decent argument for something that you can do and move. Ideally, you move a lot of heavy industry to space, and then the thing that's cool is that pollution becomes much less of a big deal, because, you imagine all the chemicals and the air pollution, all the shit that we produce to make our world, our technology, do that in a place where it doesn't really matter if you dump it in a big pit, or just, I'm not encouraging people in space to release stuff and just, into empty space, but if you do that, I mean, it's dilution is not a solution to pollution, but space is very, very big, and if you pump stuff out into space, uh, it's crazy. You're not in a place where it's going to like drift the planet, which is tricky. Um, but if you put it anywhere near escape velocity, you could imagine just dumping stuff and then it becomes so wispy, even if it's very bad stuff, even if it's highly radioactive, for example, it becomes so wispy that it's, not a big deal. Now, don't get me wrong, it's easy to imagine people doing that kind of stuff at scale and then fucking up the whole solar system. I do think that's a possibility. It's a depressing thought. But, and there's always like Kessler syndrome kind of thing, which I hope doesn't happen. But I think there's a decent chance of like heavy industry in space, mining up there, and then when you start mining and building stuff up there, it changes a lot of economics. And especially when you start having like autonomous systems that can do the mining and the building, you could imagine building space platforms. I mean, I was kind of half like joking about the O'Neill cylinder, but you could imagine if you're a billionaire and you wanted your own little private, Connecticut or small state worth of surface area, that's basically just a nature preserve just for you. There's enough material up there to do that, and many times over. You could probably do it. And if you have autonomous systems that can do it in exchange for basically just energy and programming, you could do it in a relatively short period of time. And yeah, it's a crazy thing to think of. So I'm cautiously optimistic about some things like that. I am also, it's depressing in a way to look at the moon and see people landed there in the 60s, and we haven't gone back. The 50th anniversary has come and gone. But, and I think this is important, Lewis and Clark explored the Western United States and then came back, and it took damn near 50 years, maybe a little bit more even, before other settlers really started venturing out into those areas. And when you think about it, on that time horizon, maybe that's just how long it takes people to go into a new frontier. And you start imagining like where things could go if people in substantial numbers are on the moon or in orbit or on Mars or wherever. And especially, I don't know, I'm excited about that. I think now there are very good and very bad things you could imagine, of course, but I'm a generally cautiously optimistic person, so I think and hope it may work out, but we'll see. To you watching this or listening, it might be old news to you. And whatever the outcome may seem completely obvious, but at this moment, certainly not. So anyway, I'm going to wrap up pretty shortly. I do want to say one thing because tomorrow I'm doing my stage check for flight training, which is basically, it's the 4th stage check, which is a practice flight and a practice oral exam, and it's basically like a mock check ride. And the check ride is the last barrier before I get my my pilot license. My check ride is scheduled a week from Saturday. Tomorrow is Friday. So I've got tomorrow and then about a week to do any catch up or like mopping up before that. And then assuming I pass, I will be a private pilot, which is knucking thoughts. Even if I didn't pass, I do think I would pass the second attempt, but I really do hope that I make it on the first one. I'd like to not, just for the cost alone, it's like, plus the cost of the plane, which is not cheap, and I have to pay the guy who does the check ride like $700. I'd like to not have to do that twice. Cautiously optimistic that I'll pass, but again, we'll see. I went out today with my my instructor, and I feel like some things are starting to click. One of the things that I really started feeling okay about today was airspace, which is just a mess. I mean, I understand why it's kind of a thing you have to do, but some of it is very easy and makes sense. Like, above 18,000 feet up to, into the 60s. Well, you call it flight levels above there, but 18,000 feet up quite a ways, you have something called Class A. And in Class A, it's just IFR. VFR flight rules don't apply. They don't exist. Everybody who's up there has to be on a flight plan. They have to be coordinated by air traffic control. It's like the serious professional people, military, commercial, whatever. And then you come down below that, and then it's like, okay, well, there's Class B, which is like Phoenix Sky Harbor airspace, and it's this like basically inverted wedding cake of tiers. Near the airport, it goes all the way to the ground, and then it kind of comes up, and then it comes up again, and then it starts becoming like a big fucking mess. Like, you have the airport that I'm at is Class D, and that airport is like a cylinder of Class D that goes up to 3,000 feet above mean sea level. And then you go to like Tucson, it's Class C, and that's a little layer cake thing too. There are different rules and all of these things about like cloud clearances and separation and all of this stuff. Class Gulf is kind of like down by the ground, relatively, arbitrary what you can do there. And it's complicated. And the Class Gulf in particular has a lot of weird rules. I mean, I don't mean that the rules are weird necessarily, but I mean, like, it has differences between day and night, cloud clearances and visibility requirements, and then it just, based on the height, has differences, and it just gets complicated, and you have to memorize all that stuff. And it's not something that made a lot of... I'm good at remembering things when there seems to be like an underlying reason to them, and I can just kind of rederive it from the seeds. But this is something where it's more just like, okay, this is the rule and you have to memorize it. And I mean, some of these are reasonably standardized. Like, in some things, it's like, okay, you have to be 500 feet below a cloud, or at least 1,000 feet above a cloud, and 2,000 feet separate. But then, it's like, okay, well, are you in, above 10,000 feet? You have to be like 5 miles away from clouds. And you have to be, you need to have 5 mile visibility. Yeah. 1,000 feet above, 1,000 feet below, and 1 statute mile away from the clouds. And then you go into these other ones, and it's just like 3 statute miles, or 1 statute mile, or clear of clouds, or and they're all in here, and I've got them kind of more or less, but the process of getting them into my head was not fun. And it's just, I don't think that's just me. I think part of it is just, it's needlessly complicated and not very systematic, let's just say. Anyway, with that, hopefully the next time I record one of these, actually, I guess I'll do one next week, which will be before my check ride. So 2 weeks from now, I will either be a private pilot or I'll have to do another check ride, and I hope it's the former. We'll see. I'm excited. But anyway, perseverance. Thank you very much, and 再见.